Welcome to Guide Guru. We hope this video helps.
You begin by opening Matlab and creating a script. This gets reproducible code. Define the integrand with @x for numeric work or sims_x for symbolic. This choice matters because numeric is faster, symbolic gives exact results. Once done, set limits like a and b, and decide tolerance, for example 1e6, because precision controls runtime. Make sure to name variables clearly so you avoid accidental overwrites. This reduces bugs and clarifies whether you will call integral, integral2, or int. You now execute the actual integration. For numeric, call integral @x fx a b abstol 1e6, so Matlab adapts intervals automatically. This is efficient for smooth integrands. If you need exact forms, convert to symbolic and call int, because symbolic solves analytically when possible. Once done with a numeric result, consider using integral2 or integral3 for 2 or 3 dimensions. These accept function handles and similar tolerance options. Make sure you finish by validating results. Compare numeric output to symbolic int or increase precision to see convergence, because stability shows correctness. If results look off, plot the integrand across the interval to spot singularities or oscillations, and then split the domain into subintegrals if needed. Once done, use Matlab options like waypoints or set rel tol/abs tol, and use try-catch or breakpoints to capture errors. This troubleshooting step prevents silent failures and speeds up debugging.
Thanks for watching. Consider subscribing if we helped you today.